All right, so this problem says a vector field is pointed along the z-axis. Okay, so there is the direction, and the magnitude is given by alpha x squared plus y squared, alpha divided by. Find the flux of the vector field through a rectangle in the xy plane between x equal to a and b and y equal to c and d. Do the same through a rectangle in the yz plane between z, a and b, z between a and b and y between c and d. Leave your answer as an integral. Okay, so let's do part A. So let's draw our axes like that: x, y, z. So for part A, the flux of the vector field through a rectangle in the xy plane between A and B. So here's A and B, and y is between C and D. C and D. So there is the, so this dimension is D minus C, and this dimension is B minus A. And the vector field is pointing in this direction. Okay. And what you can see is, what you can see from this functional form, x squared plus y squared is the greatest in this corner, so v is the smallest in that corner. Okay, so v will be the smallest in this corner, and it will be the greatest in this corner. Okay, so that's how the vector field looks like. And what you want to do is find the flux. Okay. Anyway, so the flux is given by, okay, so the flux for the vector field is given by v dot dA. Okay. And right, I'm just going to write it here. V, the vector field is alpha x squared plus y squared z hat, and dA is dx dy z hat. The area vector is also pointing in that direction, and so the z hat. All right, so z hat dot z hat is 1, so this integral is alpha x squared plus y squared dx dy. That's the flux. That's the flux through this surface for that vector field. Okay? So we'll do the same thing for part B. Let's see. Can I fit it in here? I think B is, no, I'll just add another page. So for part B, what is it that asking? Do the same through a rectangle in the YZ plane between, okay. Okay, so the area in the YZ plane is there. The area vector is in this direction, and the vector field is in that direction. And you can see that V dot, okay, let me write this. So V dot dA is alpha x squared plus y squared z hat dotted with dA is dy dz x hat, and this is equal to 0. So the flux through that is 0, but you can see that from the diagram. The vector field is pointing in that direction, and the area vector is that. So there's no flux through this area. Okay. All right. Same would be true for the xz plane. Okay. All right, that ends that problem.